Uh, for chapter 5, the topic is loops, files, and random numbers. So what are the key topics in this chapter? For example, let me give you an example. Let's assume, so we have like more than 40 students in this class, ISM 3232. We have more than 40 students. And I want to process the student file for each student in this class, okay? And in this case, basically, I have to run the similar code for each student, okay? I have run a similar code for each student. And in this case, so one option for me is to write one code for each student, which means I have to write a similar code in 40 times. Another method is to run similar code for each student. It means I need to run the same part of code for 40 times. Okay, that is the second method. So in this case, we need to use loops. Okay, loops. So another example is when you start to work on in a company, right? When you process your data set. So usually in a data set, you have an Excel worksheet, assume, okay? For example, typical Excel box, you have, for example, a couple of thousand or 100,000 lines of data. So in order to read the data, process the data, right? You have to use a loop. Okay, you have to use a loop to read each individual line or each individual data entry, okay? So in this case, we need to use loops. In this chapter 5, so we are going to learn this loop structure, okay? So before that, we need to study a little bit more about list boxes. Why we need that? Because so the loop structure we learn in this chapter will be used on list boxes, okay? So list box controls have various methods and properties that you can use in code to manipulate the list box's contents. The first one, it is items.add method, allows you to add an item to a list box control. For example, we have this is the name of the list box and without items.add. This is items.add method. What is that? Basically, we want to add one item to the list box, okay? For example, if we already have 5 different classes in the list, and we want to add a 6th one. In this case, we can use this items.add methods. So where list box name is the name of the list box control, and item is the value to be added to the list. Another method is items.clear method. Question?
The list box is the same as one, right?
Yeah. Just with a different method, okay? We introduce some other methods which are useful for list box, okay, list box controls. So the items.clear method can erase all the items in the items property. So it means that if we do not want these items, we can use items.clear method, okay, items.clear method. The items.count property gives you the number of items in a list box. For example, in this example, num items equals list box name dot items dot count. Basically, we can have how many items are in the list. So where the list box name is the name of the list box control, and num items is an int variable used to store the count of list items. So for this slide, you need to remember we have this kind of methods, okay? In your project, if you need to use, for example, I need to add some items to list, you need to understand, so we need to use items.add method. If we want to clear all the items in the list box, we need to use items.clear method, okay? So we have something more about list boxes. We also have sorted property can be used to automatically sort the items in the list. For example, we have a list box names.sorted equals true. This property can also be set in the property windows, okay, window. The selected event occurs when the user makes a selection from the list. Okay, for example, if you double click the list box, you create a my list box selected index changes. So you have message box message.show. Thank you for indicating your selection or your selection. So the methods, properties, and events described on this slide and the previous slide can also be applied to combo boxes. Okay, we learned last time list boxes and combo boxes are very similar. Okay, but they have some difference in in the interface design. So these are some examples. You can add stream values to a list box control like this. Names listbox.items.add Chris. Okay, we can names listbox.item.add. We have first name text box.text. We can also add names listbox.items.add color choices. Color choice is a string variable. Basically, the idea is for this items.add method, you need a string inside. Okay, you need a string inside. You can add values of other data types as well. For example, in this case, you can add 10.5. You can add player age, which is a numeric variable. So in C#, they can transform numeric values to string values, then display it in the list box. Okay, either way is fine when you use this items.add method in your project. Okay, in your project. So we have some examples. Assume that we have a list box control named location list box. Add the item Tampa to the list box. In this case, we want to add Tampa. Okay, you need to put a string Tampa. So if for the second example, assume that we have a list box control named name list box and a string variable full name dot add. The full name, add the variable to the list box. Okay, in this case, full name is a string variable, so you can put full name in the items.add method, and this variable, the content in this variable will be added to the list box. Okay, here are some examples. So then we have iteration code structure. Why we need to learn list box before we learn iteration structure? Because in this course, okay, in this chapter, you will learn how to read data from the TXT file. For example, your TXT file, you have kept some data, how we can read data and read the input and put the input to the list box. For example, you have 5 courses, right, in a TXT file. In order to read all these 5 courses and add these 5 courses to the list box, we need to use iteration code structure. Okay, that's why we learned some methods for list box before we learn iteration code structures. So we have experienced the use of sequence code structure in C#. All the statements are executed in sequence, right? The first line, when the first line finishes, then we move on to a second line. Okay. Sequence order, which are simply collections of code statements that execute one after another. Okay. We have also covered decision structures, also called selection structures, that allow a program to branch code execution. Okay. Conditionally executing some statements. For example, we learned an example if your final grade is above 92%, you got a letter A. That is a condition, okay? So decision structures. Now we cover iteration code structures, also called repetition structures or looping structures, that allow a program to execute a statement or block of statements multiple times. The keyword here is multiple times, okay? So we have same structure, but we need to run it for multiple times, okay, multiple times. So for iteration code structure, the process of repeating a series of statements is referred to as looping, okay? Looping. So we have loops and looping. A group of statements to be repeated is a loop. So in this chapter, one we will use the term loop. It means this part of code is executed once. Okay, once is a loop. One single execution of the loop statements is called an iteration. Okay, we have a structure of statements. So one single execution of all the statements inside this structure will be called an iteration. So I will going to use the term loop and iteration. So you need to understand, so what are those two terms, loop and iteration, okay? Loop is a group of statements to be repeated. One single execution of the loop statement is an iteration, okay? So basically, in this chapter, we have three different types of loops. The first one is while loop. The second one is the for loop. The last one is the do while loop, okay? So we will introduce each iteration structure in details, okay? So when you study this chapter, you need to understand each individual type, okay? How it works. When you should use it, you have to be very clear, because sometimes if you are confused about the loop structure chosen by you, you choose that and use that in your project, then there will be some logic errors, okay? You have to be very clear about how each iteration structure works. You have to be very clear, okay? You have to be very clear. So let's start from the first loop structure, the while loop structure. By the way, okay, for these three different loop structures, the while loop, the for loop, the do while loop, okay, these structures are common in all advanced programming languages, okay? So these three different types are common in all advanced programming languages in the future. Okay, for example, in next semester, so you will learn Python for data analytics or business analytics. Okay, you can take that course. So in Python, when we do iterations, you have these three different iteration structures. They are almost the same. Okay, in C++, you have these three different types of iterations. Okay, they are common in all kinds of advanced programming languages. That's why I mentioned. So if you're new in computer programming, and if this course is a first course for you to learn computer programming, try to spend a lot of effort. Okay, why? Because if you learn this C# language well, all the other languages will be very similar. It is not quite different, okay? There is some difference for sure, okay? But it is not quite different. The key concept, the key structure, the key ideas are very similar. Only thing maybe how to write a statement. That is a little bit different, okay? But the key ideas are very similar, okay? In this chapter, we have three different types of loops. The while loop, the for loop, the do while loop. These three different loops exist in all advanced programming languages. Okay, you will see that if you learn other languages in the future. So the first loop structure is the while loop. The while loop causes a statement or set of statements to repeat as long as a Boolean expression is true. Okay. So there are two parts in a while loop. The first one is a Boolean expression that is tested for a loop value, for true or false value. The second part is a statement or a set of statements that is repeated as long as the Boolean expression is true. Okay. So the flow chart of the while loop is displayed in the slide. It is like this, okay? So let's study the details in this flow chart, okay? You see the incoming flow, okay? For the while loop is here. So the first step for the while loop is to check the Boolean expression. That is very, very important, okay? The first step is to check if the Boolean expression, the condition is true or false. That is the first step, okay? If the condition is true, you go inside the loop statement and execute the statements inside. When we finish, we go back to the beginning and check the Boolean expression again. If it is true, we go inside and execute the statements again for the second time. Then we go back to the beginning and check the expression again, right? We keep doing this loop until when we find the Boolean expression is false. We jump out this while loop, okay? Here the key idea is when we want to execute the while loop, the first step is to check the condition. Okay, you will see why I mentioned this. The first step is to check the condition. If the condition is true, we execute the statements inside. Otherwise, we jump over the whole while loop. Okay, you see, because the first step is to check the Boolean expression. Then it is possible for the first time when we check the Boolean expression, the expression is false. It's possible. Okay, when it is false, we will jump over the while loop immediately. No statements inside will be executed. It means, in other words, so for the while loop, it is possible that we will not execute the statements inside the loop at all. Because when we find the Boolean expression is false in the very beginning, we jump over. Okay? So it is possible that we will execute 0 times of the statements inside the loop. Okay? 0 times. So structure of a while loop. So in C#, okay, actually in other languages like C++ or other languages, the structure is almost very similar, okay? So we have the keyword while, okay? And after while, we have a pair of parentheses. So inside this pair of parentheses, we have a Boolean expression, which is a condition, okay? Then you have a pair of curly braces, Inside this pair of curly braces, we have the statements, okay? So the C# will work as follows. So when we reach to this while point, C# will check this Boolean expression first, okay? If that expression is false, C# will jump over the whole while structure and move on to the next statement after the while structure, okay? The whole while structure. Otherwise, if the Boolean expression is true, C# go inside the while loop, or go inside here, and execute the statements, okay, inside the while loop. Once C# finishes all the statements, so we will go back to the beginning and check the Boolean expression to see if it is true or false. Okay, if it is true, we will execute the statements again, then go back to check the condition. If the expression is false, right? In this case, we will jump over all the while structure like this and move on to the next statement. Okay, move on to the next statement. So in the slide, we can see that the first line is called the while clause, okay, which is use the keyword while. Statements inside the curly braces are the body of the loop, okay, the body of the loop. When a while loop executes, the Boolean expression is tested. If true, the statements are executed. Recall that each time a loop executes its statements, we say the loop is iterating or performing an iteration. It means if it is true, right, we execute all the statements. When we go back, we see that we perform one iteration, okay, iteration. So this is the structure of a while loop, okay, a while loop. So the while loop is test loop. So while loop tests its condition before iterating. That is the key sentence, okay? Before executing any statements inside the body, loop body, the while loop will test its condition. So it is a pre-test loop or pre-test loop. So for example, so we declare a counter variable with an initial value int counter equal. Then the while clause will test its Boolean expression like this, right? While count equals less than 5. Then we have a pair of curly braces. And for now, nothing is inside the pair of curly braces, okay? So before we continue, let's see this example to see what's going on here, okay? To see what's going on here. So let's analyze the while loop for a couple of iterations. So the int, the value of the int variable count equals 1, okay, equals 1. So when we check the condition, count less than 5, 1 is less than 5 for sure. So the condition is true, so C# will go inside the while loop body, right? In loop body, we have no statements, it is empty, it's fine. So when C# finishes, C# go back to the condition, count still equals 1, right? So 1 is less than 5, condition is true, go inside this empty body, go back and check the condition, 1 is less than 5, condition is true, so move to the body, go back and check 1 is less than 5. You see, so it seems the condition is always true, okay? And C# will always stay in the while loop. It means it's a dead loop, okay? It is a dead loop. When you have this kind of loop structure in your code, you will see and you start to run your application, you will see that your application is dead, is frozen, okay? It is. So basically, you should avoid this kind of problem. You should not put dead loops in your code because that will make your application to be dead, okay? So inside the curly braces, there must exist a statement that defines an increment of the counter. You see, inside here, we have one statement, count equals count plus 1. Question? Yeah, forever. You have to cut off, right? You have cut off C# to stop it by force, okay? So that's why it is always important. So make sure that the condition will be updated, right? In the body loop, body of the loop. Otherwise, if the condition is not checked, it is not changed, it is always true, right? So C# will stay inside forever, okay? There will be no time that C# can jump out or move to next statement. So it's dead, okay, it is dead. So the first thing you need to remember is never put, right, dead loop in your project, okay? When you use a loop structure, the condition has to be able to be updated somewhere. Otherwise, it's a dead loop, okay? It's a dead loop. For example, in the example in the slide, this one, we still have the condition count is less than 5. The difference is we have a statement to update the value of the int variable count. Count equals count plus 1. Okay, count equals count plus 1. It means in the beginning count equals 1, right? 1 is less than 5, so the condition is true. We go inside. So count equals count minus 1. So count now equals 2, right? So go back to check the condition. 2 is less than 5. So the condition is still true. So we have count equals count plus 1, count equals 2, so count now equals 3, right? 3 is less than 5. So still the condition is true. Go inside, 3 plus 1, count equals 4, right? 4 is less than 5. Count equals count plus 1. 4 plus 1, it means count now equals 5, right? 5 less than 5, that condition is false. Okay, it is false. So count equals 5. So the condition of the while loop is false. So C# will jump out and move on to the next statement after the while loop. Okay, after the while loop. So based on what I have just described, you see, when count equals 1, right? We execute the loop once. Count equals 2, second time. Count equals 3, third time. Count equals 4, the fourth time, right? When count equals 5, see the condition is false. C# will jump over. It means we execute the while loop 4 times. Okay, right? 1, 2, 3, 4. When count equals 5, so the condition is false. So we do not execute the while loop. We jump over, right? So in this case, we execute the while loop for 4 times, okay, not 5 times, okay? So for this kind of analysis, you have to be very clear. For example, when you write count less than 5, we intentionally design the loop to run 4 times, okay? You have to be very clear, okay? You have to be very clear. So sample while loop code, okay, we have the go button click. So for this go button click, we have int count equals 1, while count is less or equal than 5, message box dot show hello, count equals count plus 1. So in this case, right, let's see, when count equals 1, so count less or equal than 5, that condition is true. So we go inside, we see the hello, right, hello once, okay? Then we update count plus 1 is 2, right? 2 less than 5, we will see the message hello again for the second time, right? We update count equal to 3, 3 is less or equal than 5, that condition is true. We see the message hello again, right? For the third time, we update count to plus 1 to 4, 4 is less or equal than 5, we see the hello message for the fourth time, right? Then count plus 1 equals 5, 5 is less or equal than 5, that condition is still true, right? So we see the message for the fifth time, right? We go inside, count equals count plus 1, now count equals 6, right? 6 is less or equal than 5, that condition is false. So we jump over, basically based on what I just described, okay? You see, for this example, we will see the message hello message for 5 times, okay? We will see the hello message for 5 times. That is the first observation. The second observation is when we finish the whole while loop, okay? When we finish the whole while loop. So when we finish the whole while loop, count equals 6, not 5, okay? You see, I just analyzed all the iterations for this while loop. Basically, we will run the loop for 5 times. It means we will see the hello message for 5 times. But when the while loop finishes, the variable count, the int variable count, will equal to 6, okay, not 5, okay? So for this kind of analysis, you have to be very clear, because when you work on a big project, okay, the first step is to clear all the syntax errors. You finish the coding part. You have to clear all the syntax errors. Usually this step is not that difficult. Why? Because C# will give you a hint. For example, so you miss a semicolon in line 147, right? It means in this line, you need a semicolon. You get hint from C#. However, if you make a mistake in your logic, for example, you make a mistake for the value of the count. So, or you miscount the number of times so that the loop will be executed. Okay, you make that mistake. You will not get any hint from C#. Okay, it seems everything looks fine. However, the results are not correct. Okay, the results are not correct. So in this case, you have to be very clear about these kind of things because that's the key. So for you to debug a big project, the count has an initial value of 1. Each time the loop executes, 1 is added to the counter. The Boolean expression tests if the counter is less than or equal to 5. The loop will stop when the counter exceeds 5. Okay, this is a very simple description of this while loop structure. So this is the dead loop or infinite loop I just mentioned. An infinite loop is a loop that will repeat until the program is interrupted. It means you will see your application is freezing, okay? So there is no response, no matter what kind of input you want to click or type. So your only option is to kill the program or stop the program, okay? A typical cause is that the programmer forgets to write code that makes the test expression false. So you forget to update the test expression. It means when C# finds the expression is true, it goes inside, right? And stays there forever. That's a problem. So in the following example, the counter is never increased. So the Boolean expression is never false. In this case, for example, count equals 1. The condition for the while loop is count is less or equal than 5. Okay. And inside the while loop body, we have message box.show hello. But there is no statement to update the value of the int variable count. It means if you have this couple of lines of statements in your application and you start the application, you will see your application is dead. Okay, it is dead. You have to kill the program or terminate the application by force. Okay, so this is an infinite loop. Okay, this is an infinite loop. So we have one example here. Assume we have two int variables, x equals 3 and y equals 5. What are the values of x and y after the following statements? So we have int count 0. So in the condition we have while x is greater or equal than 1 and counter is less or equal than 4. So we have y plus equals 1, x minus equals 1, counter plus equals 1. Okay. So for this example, this is not a very easy example. Okay, this is not a very easy example. Okay. So in this course, you should be able to analyze this kind of example by yourself. Okay, by yourself, without any problem, because when you deal with algorithms in business analytics, okay, algorithms in business analytics. So you have to write code like this. This is part of your code. And when you debug your code, okay, debug your code. So you have to be very clear about how C# or how Python, how C++ run each step, okay? You have to be very clear, okay? You have to be very clear. So now let's analyze this example together, okay? Analyze the example together, okay? So I copy the example here. Sorry. Okay, I have this. Let me copy it line by line, maybe better. Okay. Let's analyze it together so you will see how it works. Okay, how it works. We have this. We have that. Here we have curly braces. Get some indentation. Okay. Let me put them a little bit bigger. Okay. Okay. Okay, looks better. Okay. So this is the example. Okay, this is the example, and we have. Let me put this like here. So let's analyze this example together. Okay, count equals 0. Okay, count equals 0. Okay. I need this. Okay, iteration 1. Okay, for let's see iteration 1. Okay. So for iteration 1, count equals. We start. We know count 0. Okay, count equals 0. Now let's see the condition. Okay, in the while loop, remember the while loop is a pretest loop. It means before executing the statements inside the loop body, so we need to test the condition. Okay, so the condition is x is greater or equal than 1 and counter less or equal than 4. Okay, that is the pretest condition. Okay, so let me zoom a little bit. Okay, so the condition is x is greater than 1. The example is x is 3, y equals 5. Okay, x equals 3. Let me see. X equals 3, y equals 5. Okay, before the before we execute the loop structure. So let's check the condition. Okay, so x equals 3. So x equals 3. Okay, so 3 is greater or equal than 1. So it is true. Okay, the condition is true. Okay, it is true. So the second condition it is counter is less or equal than 4, right? Counter is less or equal than 4. So we know that counter equals 0, right? Counters equals 0. So 0 is less or equal than 4. So that sub expression, it is also true, right? It is also true, okay? It is also true. So we have an AND, right? AND logic operator. So we have true and true for this logic operator, okay? For the logic operator. Okay, true and true. So we have this. So it will give us true, right? True and true, it will give us true. So let's mark this. Okay, it is true. So if we go back to this loop structure, so the condition for the while loop is true. Okay, when we analyze it, the whole expression, this expression, compound expression, it is true. Okay, it is true. So we go inside. Okay, so we go inside. When we go inside, the first statement it is y plus equals 1. Okay, we have learned that is equivalent to y equals y plus 1, right? Y equals y plus 1. So y equals what? Y equals 5, right? Y equals 5. So y equals 5. So y plus 1 equals 6, right? So y equals 6. After the statement, y equals 6. Okay, y equals 6. The next one, it is x minus equals 1, right? So it is equivalent to the statement x equals x minus 1. Okay, x minus 1. So x equals 3, right? X equals 3. So we have x minus 1. 3 minus 1 equals 2. So we have x equals 2 after the statement. Okay, after statement. So the next one, it is count. Counter plus equals 1, right? So it is equivalent to counter equals counter plus 1. Okay, counter equals counter plus 1. So counter equals what? It is equals so counter equals 0 plus 1, 0 plus 1 equals 1, right? Counter equals 1, okay? Counter equals 1. Counter equals 1. So after the first iteration, you see we have finished all 3 statements. Let me see if there are any question. No. So when we finish all the statements in the first iteration, okay, it is not iteration. So we have x equals 2, y equals 6, counter equals 1, right? We have this is the outcome. Let's mark it, okay? Mark it with a different color, which is, let me use green, okay? Let me use green to mark it, okay? So when we finish the first iteration, we have x equals 2, y equals 6, counter equals 1, okay? Counter equals 1. So let's go back to the second iteration, okay? So we copy the format. In the first column, we have counter equals, copy it from here, right? in the beginning of the second iteration, we copy the value in the end of the first column. It is counter equals 1, x equals 2, y equals 6. Okay, counter equals 1, x equals 2, and y equals 6. Okay, y equals 6. And we need to check the condition, which is similar, the same, which is x is greater or equal than 1, and counter is less or equal than 4. Okay, so we have x. So let's have x equals 2, right? X equals 2. So x equals 2. So 2 is greater or equal than 1. So that is true, right? And still true. Okay. So the next condition is counter equals 1, right? So counter is less or equal than 1. So the condition is counter is less or equal than 4. So 1 is less or equal than 4. So the condition is this sub-condition. So it is also true, right? It is also true. So we have true and true condition, which can give us another true, okay? Okay, true and true. We have another true for this in the second loop. So we move inside this while loop. We have y plus equals 1. Okay, we can copy this now. So y plus equals 1, it is equivalent to y equals y plus 1. So in the beginning of the iteration number 2, y equals 6. So y plus 1, 6 plus 1, now y equals 7. Okay, y equals 7. So for next statement, x minus equals 1. So we have x, it is equivalent to x equals x minus 1. X now it is 2, right? It is 2. 2 minus 1, it is 1, right? It is 1. So the third statement inside the loop body, it is count plus equals 1. Okay, count plus equals 1. So count is equals 1, right? So 1, it is equivalent to count equals count plus 1. 1 plus 1, it is 2, right? Count equals 2, okay? So in other words, when we finish the second iteration, I have x equals 1, y equals 7, counter equals 2, okay? So these are the values of x, y, and counter after we finish the second iteration. Okay, after we finish the second iteration, okay? So now let's move on to next one, iteration number 3. Iteration number 3. So before we do anything, we can have so counter equals 2 based on what we have analyzed in iteration number 2, okay? Counter equals 2, x is 1, y is 7, okay? X equals 1, y equals 7, okay? We have a similar condition, which is x is greater or equal than 1, counter is less or equal than 4, okay? So we analyze each sub condition, okay? So x now equals 1, right? 1 is greater or equal than 1, that condition is still true, okay? So for the second sub expression, counter equals 1, counter equals 2, right? Counter equals 2. So 2 less or equal than 4, the second sub expression is also true. So we can have true and true for the whole compound expression. Okay, for the whole compound expression. True and true, we can have true, okay, for the compound expression. So the condition of the while loop is still true in iteration number 3. So we can have similar analysis, y equals, let's put all this here. So y plus equals 1, it is equivalent to y equals y plus 1. So y is now 7. 7 plus 1 equals 8. Y equals 8, okay? Y minus equals 1, x equals x minus 1. So x equals 1, right? 1 minus 1, x equals 0. Okay, x equals 0. So counter plus equals 1. Counter now equals 2. 2 plus 1 equals 3, right? Equals 3. So as the result of the values of x, y, and counter, after we execute the iteration for the third time, will be x equals 0, okay? Y equals 8, okay? Counter equals 3, okay? Counter equals 3, okay? We have finished 3 iterations, okay? For while loop, C# will go back to the beginning of the loop condition and check if the expression is true or false. Again, okay? Let's see if we can have iteration number 4, okay? I put here independent place. Iteration number 4, okay? We have this part. Let's see. So okay. So after the third iteration, counter equals 3, x equals 0, y equals 8, right? Those are the values of x, y, and counter after we finish the third iteration. So x greater or equal than 1, the first sub-expression. Counter is less or equal than 4, the second sub-expression. So x now equals 0, right? So 0 equal greater or equal than 1. For that sub-expression, it is false. Okay, it is not true. So counter now equals 3. 3 is less or equal than 4. The second sub-expression is still true. Okay, it is still true. So we have false and true, which can give us false, right? For an expression, we need both sub-expressions to be true in order to get a true return value, okay? So we have false, okay? So now when C# checks the condition again in iteration number 4, right? C# can find, oh, this compound expression returns a false value. So C# will jump over, right? The whole while loop structure without executing any statements inside. C# jumps over all the whole structure and move on to the next statement. Okay? So based on this analysis, okay? Based on this analysis, we can find in this while loop, right? So the while loop will be executed 3 times. It means we have 3 iterations in total. Okay, when C# tries to execute this loop for the fourth time, the condition is false. Okay, the condition is false, so there is no the fourth iteration. Okay, you see, I have spent more than 10 minutes on this example. Why? Because when you design your loop in your project, you have to be very clear about how it works in these details. Okay, each step when we move on, we are 100% clear about the value of each individual variable. You see, in each iteration, right, we have the analysis of all the details. Okay, all the details. We are clear about the value of all the variables x, y, and counter after we finish each individual step. Okay, and we have all the values when we finish one iteration, right? So when you analyze your own problem, when you do especially when you work on a big project, coding project, business analytics coding project, okay, data analysis, okay, and you find, oh, I just finished my code and I have fixed all the syntax errors, but my results are not correct. What's going on? Then when you debug your code, you have to do this by yourself, okay? Run the code step by step by yourself, because what is debugging? Debugging means you allow C# to run code in C#, okay? Run it for one step. Then you run the code in your mind by yourself to analyze the results, all the from each step. You want to see, so the values of the variables from C# match the values in your mind. If they match each other, usually there is no problem in this single step. You can move on, okay? However, if the value from C#
Maybe there
is different from the values in your mind, then there is some problem. You find where is the problem, and you need to dig into that and fix the problem. Okay, fix the problem. Okay, so this is why I spend so much time on this simple single example. Okay, so in today's quiz, you will have one problem, only one problem, similar as this one, right? And I will ask you to analyze the values of some variables, basically. So you need to follow what I have written here, right? Show the details of the analysis. Okay, show the details of the analysis, okay? So it is also very important in the exam, because in the exam, you will also have some similar question to analyze the values of some variables. So you need to show your work, like what I have showed here. Okay, show here. If you skip all the details, okay? So for example, if the question asks you what are the values of x, y, and counter after we finish the loop, so you skip all the analysis, you just give me some numbers, okay? So you will not be able to get all the points, because I have no idea how you get those numbers, okay? You need to show your work, because I want to make sure that you understand how to perform the analysis, how to conduct the analysis, okay? How to conduct the analysis. Okay, that is my comment, okay? Okay. So this is this example. You see, the answer is x equals 0, y equals 8, counter equals 3, okay? Even though I only show the numbers in the slide, when you write your own answer, okay, in today's quiz or in the exam, so you need to show the analysis, okay? Show the analysis to prove that you understand how to analyze this kind of problem, okay? Because this is key for you to debug your code in the future. In this course, it may not be very important. Why? Because to be honest, all the labs and assignments, they are not difficult. need to start with some simple examples, okay? But in practice, or we'll take advanced courses, okay? So the program you will build will be large projects, okay? You need to write hundreds, thousands lines of statements. In those cases, you need to be able to analyze your code in this way. Okay, this is the only way you can figure out all the logic errors and make your code working. Okay, that is very, very important. So this is this example. We also have plus plus and minus minus. Okay, to increment a variable means to increase its value, and to increment a variable means to increase its value. C# provides plus plus or minus minus operators to increment and decrement variables. Okay, so you want to add one to a variable, you can use count equals count plus one, or count plus equals one, or count plus plus. Okay, so if you want to subtract one from a variable, you can do count equals count minus one, count minus equals one, or count minus minus. Okay. So as a professional programmer, when we want to increment or decrease the variable by one, you usually will use this last one, count plus plus, or count minus minus. Okay, count minus minus. So postfix mode versus prefix mode. Okay, so postfix mode means to place the plus plus and minus minus operators after their operands. Okay, like count plus plus. Prefix mode means to place the plus plus and minus minus operators before their operands, like minus minus counter count. A difference exists in the two approaches only when the operators are used with other operators in more complex expressions. So let me use, this is a little bit complicated concept, okay? So what is count plus plus or plus plus count? What is the difference, okay? So let's see this example. Int x equals y, there's no value for y equals x plus plus, okay? Y equals x plus plus. You see in this case, right? Plus plus is after x, okay? The two plus signs are after x. So it means for plus plus are after x. So we will do x equals y equals x first, then do. Okay. So in this case, let me use notes here. Okay. So in this case, we have y equals x plus plus. Okay. So this expression, this statement, is equivalent to two statements. First one is y equals x. Second one is x plus equals 1. Okay? Because now plus plus is after x, we will do y equals x first, then do x plus plus. So because x equals 1, right? So we do y equals x first, so y equals 1. Then we do x plus plus. We increase x by 1, so x equals 2. So after these two statements, x equals 2, y equals 1, okay? But for the example on the right, we have x equals 1 and y, but we have y equals plus plus x, okay? So for this one, y equals plus plus plus. So it is equivalent to, because now plus plus is before x, right? So we do x plus equals 1 first, okay? Then we do y equals x. Because in this case, plus plus is before x. So if we go back, x equals 1, we increase x by 1 first. No, now x equals 2. Then we do y equals x. So y also equals 2. Okay. So for the example on the left, x equals 2, y equals 1. For the example on the right, x equals 2, y equals 2. Okay. Y equals 2. Okay. So here is one example. Assume there is a int variable count and write a statement to add 1 to the variable count. If that is a problem in the exam, okay? So I provide 3 different answers. The first one is count equals count plus 1. The second one is count plus equals 1. The third one is count plus plus, okay? If that is the case, you just need to provide one answer. Anyone will be correct, okay? Anyone will be correct. So that is the example. So the next one, it is the for loop, okay? We spend a lot of time on the while loop. With one, we now need to start the for loop. The for loop is a pretest loop, specially designed for situations requiring a counter variable to control the number of times that a loop iterates. So you must specify 3 actions. So we have initialization, we have test, we have update. You see, for the for loop, we have 3 parts: initialization, test expression, and update. Okay, update. So the logic is as follows. So in the beginning, we first do initialization. Then we check, we do this first. Then we check the expression. If the expression is true, right, we execute the statements. When we finish, we update the expression, then check the test expression. Okay? Initialize the values, test if it's true, do statements. When we finish, update, test it again. If it's true, do statements, update again, right? This is the logic. This is the logic, okay? So this is example, count equals 1, count is less or equal than 5, count plus plus. In this case, we do count equals 1 first. Test condition. If it is true, execute statements inside, okay? When we finish, update, test, okay? This is a different structure compared to the while loop, okay? Compared to the while loop, okay? So the initialization expression assigns 1 to the count variable. The expression count is less or equal than 5 is tested. If expression is true, the loop continues with step 3. Otherwise, the loop is exited. The statement in the loop body is executed. The updated expression adds 1 to the count variable. The loop repeats from step 2, but not the initialization expression, okay? So you see, you analyze. So for this one, you just have a little bit different structure, but it is still for loop, okay? It is still for loop. So other forms of update expression, okay, we can do count plus equals 10. Each time we update, we increase count by 10. We can also do count minus minus. Each time we will decrease count by 1, okay? There are multiple ways to update the count expression, So this is one example. What is the value of the int variable count after the for loop? Okay, after the for loop. So you see count equals 1, okay, initialization. We check condition 1 is less or equal than 5. So the condition is true, right? We do statements. Okay, when we finish, count plus equals 3. So we increase count by 3. 1 plus 3 is 4, right? So we check condition again. 4 is less or equal than 5. This condition is still true, okay? We do statements, right? We update count plus equals 3. 4 plus 3 is 7, right? 7 is less or equal than 5. That expression is false, okay? So C# jump out. So the count equals 7, okay? Count equals 7, okay? So the analysis will be very similar as what we have done for the while loop, right? It is just there is a little bit different flow here, okay? initialization, check condition, finish statements, update the values. Okay, this is a for loop. This is a for loop. So the last loop structure is the do while loop. Okay, which is very similar as a while loop, with a small difference. Okay, with a small difference. So the do while loop is a post-test loop, which means it performs an iteration before testing its Boolean expression. Thus, the loop statements are executed once even before the Boolean expression is tested. Okay, it is like this. We first have a do, the while is in the end. So for this do while loop, it means no matter what is the value of the expression, C# will execute statements no matter what is the value, because it's in the end. Once C# finishes all the statements, it checks the Boolean expression. Okay? If it is true, C# go back to execute statements again, then check the expression. So in other words, for the while loop, right? So we check the condition first. It means if the condition is false, it jumps out, right? But for the do while loop, no matter what is the expression in the condition, C# will execute the loop once, at least once. Okay, that is the key difference. Everything else is the same. The only difference is this. For while loop, check expression first. If it is true, execute the loop body, right? For the do while loop, execute the statement first, no matter what is expression. Once C# finishes, check the expression, right? If it is true, go back to the beginning of the do, right? Do part, okay? So that is the key difference, okay? That is the key difference. That's why we call it is a post-test loop, okay? So sample do while loop, right? Number equals 1, we do the message, while number is less or equal than 0. So here we have no update of number, right? Similar as a while loop, it will be a dead loop. Stay inside. So if we have this one, in this while loop, the message box is not displayed. But in this one, number is 1, while number is less or equal than 0, right? In this case, because 1 is less or equal than 0, that condition is false, right? For the while loop. So the whole while loop body will be skipped because the condition is false. For the first example, even though the condition is false, we will still see the message for once. Okay, once. Okay, that is why it is do while loop. Okay, do while loop. So we want to decide which loop to use. The while loop, it is pretest loop. So use it when we do not want the statements to execute if the condition is false. Okay, the do while loop, post-test loop, use it where you want the statements to execute at least one time. The for loop, pretest loop, use it where there is some type of control variable that can be evaluated and updated. Okay, for example, I want to process the student file of all the 40 students. I know there are 40 students, right? So I will intentionally design the loop to run 40 times. In this case, for loop is the best choice because I know there are 40 students. I just need a variable counter, right? And update the counter once for in each loop. Okay? For loop, usually we know that how many times we want to run the loop. Okay, how many times we want to run the loop. Okay? So this is the example. Assume we have two int variables, x equals 2, y equals 4. What are the values of x and y after the following statements? You see, we do, right? So x plus plus, x not equals 3, y plus plus, y equals 5, right? Then we check condition, x less or equal than 3. 3 is less or equal than 3, right? Condition is true, we run it again, right? X plus plus, 3 plus plus is 4, y plus plus, 5 plus plus is 6, right? Then we check condition 4 is less or equal than 3. That condition is false. Okay, we jump over. So the final answer for this problem will be x equals 4, y equals 6. Okay, and we have run the loop for twice. Okay, twice. You see, for for loop and do while loop, the analysis will be similar as what I have done here. Okay, I have shown all the details for the while loop. Okay, so for you, no matter what is a problem, while loop, for loop, do while loop, you see in the exam or in the quiz. Okay, you need to show all the details because I have no time, right, to show all the details for all the examples. So my strategy is I show the details of one example. For the other different two examples, the analysis is similar. It means that you will need to follow this structure and solve the quiz problem and solve the exam problems. Okay, solve the exam problems. Okay.